Okay, now we are concentrating today on graphing mostly linear equations, and we're going to start with equations in the form of slope intercept. So here we got a simple equation, y equals negative 3/4 x minus 1, where the slope is given to be negative 3/4, and the y-intercept is this would be intercept. It's negative 1. And if you know the y-intercept, if you know what it means, the y-intercept is the point where the line crosses the y-axis. So with that in mind, we're going to do a little rough sketch of the y-intercept goes at negative 1, and the slope, we use the slope to find a second point, because back in geometry we learned that we only need 2 points to make a line. In fact, it's said through any 2 points there exists one and only one line. So using that postulate, we're going to concentrate on using 2 points to graph a line rapidly, because this is algebra 2 now. So in going ahead and graphing this, we're going to go up 1, 2, up 3, and you're probably wondering, why am I going up instead of down? Because there's a negative here. Well, it doesn't really matter which way you go up or down, depending. The negative can be used for either the numerator or the denominator, or rather the rise or the run. Usually in our algebra 2 class, or in algebra 1 rather, we concentrate only on the negative going for the rise. If it's negative, then obviously you go down, but then we focus on keeping the run positive. But in algebra 2, we don't want to restrict ourselves. So we can say that it'll go up 3, but then the run will go to the left side. So we're going to go 1, 2, 3, and then 1, 2, 3, 4. So then our point will be somewhere on the second quadrant. And of course, you can go ahead and draw a line. Now, drawing on this thing is kind of tricky, but as you can see, since we have 2 points, we can draw our line, a rough sketch of a line. So let's try a second example, something with a positive slope this time. So let's suppose we have y equals 5/3 x, and then the y-intercept is positive 4. If we have positive 4, then the line will cross our y-intercept at point 4, label that correctly. And then this one is both positive. Again, we can both, we can go up positive and 3 positive, or we can go down down 5 and left 5. Either way, we still get a correct answer. It doesn't really matter. It's your choice, provided you are consistent. I'm going to go up 5. 1, 2, 3, 4, 5, and then of course 3 to the right. So 5 and 3 would be here, approximately there. And then we can go ahead and draw our sketch. It takes a little practice to get these things straight. Preferably, I want my students to use a ruler and graph paper. Of course, I don't have that ability in this program here. But let's try another example here. These are in slope-intercept form. Suppose you're given something instead in the standard form. Now, standard form can be easier at times, depending on what you're given. So in this case, suppose I have x minus 2y equals 6. Again, we need 2 points. In this case, we can find the x and the y-intercept to find the y-intercept, we just let x be 0. Again, if x is 0, then y would be, when you get an equation, negative 2y equals 6, and y is equal to negative 3, so we get a point at 0, negative 3, that's 1 point. And if we want to find the x-intercept, we just let the y be 0. Of course, if y is 0, then x is positive 6, right? X will be equal to 6. And then we have our point 6, 0. One of the common mistakes I see with my students is they forget, and they use, they would write 6, negative 3 as the intercept. But that doesn't make any sense because you need 2 points, so each point has a 0, and you have to remember that. All right, so graphing this one quickly, because if you're taking the SAT, you don't have time to think too much. You have to graph these or be able to recognize these very quickly. So 0, negative 3 will be down here. There's 1 point, and then 6, 0 would be on the x-axis. 1, 2, 3, 4, 5, 6, and there's your 2 points. And then, of course, graphing this would be, let's see if we can kind of, let me try that again. Like I said, this thing's a little tricky. So let's see, graphing through here, quick sketch, there we go. And of course, always use a ruler and label your points. This would be the point 6, 0, and this of course is negative 3, 0, and there's that. Now sometimes excuse me, sometimes you're given a standard equation, standard form of an equation, but your numbers become fractions, which are difficult to graph. But remember, you only need a point in a slope to graph these things. So here I can combine both methods. I let x be 0, let x be 0. That gives us y equal to 4. So I have 0, 4. And then, instead of finding the x-intercept, because you're going to get 20 over 7, and graphing that would be kind of tricky, instead find the slope by using this quick formula that we can prove, but not at this time. It says that the slope is going to be the a coefficient, which is 7, divided by the b coefficient, which is 5, and there's a negative in front of it, so this will give us negative 7 over 5, and once we have a point and a slope, we can go ahead and graph this line. Pretty straightforward, a lot easier than having to do a fraction for an intercept. So 0, 4 will be up here. I'm going to make it 1, 2, 3, 4, right about there. Label your points. That's supposed to be a 4. And then from here, I can see that I can graph either up 7 and over up 7 and left 5, or down 7 and right 5. Either way, I'm going to go down 7 in this case because it makes it easier. So here's 4, 5, 6, 7, and then to the right 5. I'm going to go 1, 2, 3, 4, 5, and that's about right about there. And then from here, you can use a ruler. Of course, I don't have a ruler, so I'm going to try, let's see, okay, so that'll work. If I can just kind of stretch it out this way, making the line going through there, and roughly you get an idea as to what the graph looks like. Let's try another example here real quick. I'm using the same approach. Let me clean this up a little bit. Move it down a little bit. All right. And then so we have, for example, the equation that looks something like this. You got y equals -2. And a lot of students probably see this and they go, well, there's no x value. Well, what I remind my students is tell them that, okay, y is a constant. It's always going to be -2, so it doesn't matter what x is. In fact, I can let them choose the x values, knowing that y will always be -2. And for any x value, let's say 0, you get y equals -2. If x is 3, you get -2, and so forth. And if you graph it quickly, you will see what kind of line you're going to end up getting. Excuse me. Suppose then if x is 0, then I'm going to be down here at -2. 1, 2. And there's your point. And if x is 3, let's pick x equals 1, 2, 3. And then y is going to be -2 again, and so forth. And of course, given any 2 points, there's a straight line. So here we can see that this line is going to be, it's close enough. It's going through, this is y equals -2. It's going to be a horizontal line. And if we can take the slope of this, we can show that the slope is 0. And put it in not standard form, but y-intercept, slope-intercept form, y equals mx plus b. We can see that if the slope is 0, I have a -2 there. We can see that the equation does indeed look like the equation above. And we can conclude from this that all horizontal lines have a 0 slope, Okay, so let's see if we can go ahead and solve some more on your own, and hopefully that will help you guys do your homework.